Okay, in this section 12.4, we're learning about the volume of prisms and cylinders. Now, this is the first section where we actually talk about volume. Up to this point, we've only been talking about surface area. And so now this is a good point as we begin to talk about volume. All right, the difference between length, area, and volume and the type of space that it measures. So we're talking about length. It's just measured in a regular unit, feet, yards, inches. It's one-dimensional, and it measures a space that looks like this, right? It's just a one-dimensional length that it's measuring. When you talk about area now, all right, that's measured in square units. For example, square feet. It measures a two-dimensional space that looks like this, all right? Two-dimensional space, okay? And so, like if this is a yard, or excuse me, if this is a foot, this would be what is known as a square foot if it's 1 foot on each side, okay? So that's where the expression square feet come from, square meters, so on and so forth. Okay, volume now is expressed in cubic units, and it measures a three-dimensional space that looks something like this. So if you've got a cube that is 1 foot on every side, then that would be a cubic foot of volume, right? So length, one-dimensional space, area, two-dimensional space, volume, three-dimensional space. And so it's important to understand what example you're using to figure out what type of measurement that you should use. Like for example, if I wanted to see, how long it was from my house to somebody else's house, I would measure that in length. If I wanted to see how much fertilizer I needed to cover my backyard, that's a two-dimensional space. I would use square feet. Okay. If I wanted to see how many boxes I could stack inside of a room, I would measure the cubic feet of the room. All right. So that's kind of the difference. All right. Now, here are my formulas. Here's the formula for volume of a prism, capital B times H. Volume of a cylinder, pi r squared h. B stands for the area of the base, just like it normally does. H is the height of the prism or cylinder, and R stands for the radius. All right. So let's go through and practice some of the problems now. Let's say I wanted to find the volume of this prism. All right. So we'll write the formula down. It's volume equals capital B times H. Always start by writing the correct formula. Now B stands for area of the base. All right. So we'll say that this bottom side is the base. And so the area of the base is length times width. So if I go 15 times 12, then, oops, that's not what I want. If I go 15 times 12, then that gives me 180. So that'd be 180 times. Now if I use that as the base, the height of the prism would be 5. And so we have our answer, 900 cubic units, whatever the unit is. All right. Okay, here's the next one that we want to look at. This is also a prism, and so I'll actually be using the same formula, capital B times H. All right. And again, B stands for the area of the base. So the first question is, what is the shape of the base? All right. So the shape of the base is a triangle, right? And so I have 12 here. I can look on to the other base to know that that hypotenuse is 15. This is still missing though. So first thing I'm going to have to use is Pythagorean theorem. X squared plus 12 squared equals to 15 squared. All right. And so again, the hypotenuse is always C. The hypotenuse is across from the 90. That's how we know. And so I can move this over to the other side. So I can do square root of 15 squared minus 12 squared. Let's see what that equals to. So when I move that over, there's probably also a Pythagorean theorem calculator that you can find in online pretty easily that would probably do this for you as well. Let me see. But if I wanted to use my Desmos calculator, I would just go the square root of 15 squared minus 12 squared, and then that is equal to 9. So 9 is the missing side. So that means this side right here would be 9. And so now I can find the area of the base because I need the base and the height. because area of a triangle is 1/2 the base times the height. So my area is going to be equal to 1/2 times, the base is 9, the height is 12. And so, let's see, half of 9 is, let's go half of 12 is 6. 6 times 9 is 54. So the area of the base is 54. So now I need to go 54 times the height of the prism, which is 10. And so that's 540. There you go. Alright, so there are times, again, since we're dealing with prisms again, that we may have to go off to the side and use Pythagorean theorem and calculate the area of the base, because B does stand for area of the base in the volume formulas. Let's try a couple more. Alright, so here's the next one that we want to look at. This is also a triangular prism. So here's my formula. Oh no, I need V there. Volume equals VH. Okay. Volume equals. Alright, so B stands for the area of the base. So I got to go off to the side and calculate it again. And get 34 there, but once again I'm going to need the Pythagorean theorem. X squared plus 16 squared equals to 34 squared. So if I wanted to figure out what x equals, I would move the 16 to the other side and subtract it, and then take the square root of both sides. And so when I, let's see, jump in here to do this, I'm going to want to change that first one to a 34. Okay. And I'm going to want to change the second one to a 16. Oops. Let's see. 16 squared. And then I can see that 30 is the missing side. Okay, so once I know that that's 30, now I can go through and do 1/2 the base times the height, which is how you get the area of a triangle. 1/2 the base we just found is 30. The height we know is 16. And so here I just need to do half of 30 times 16, which is going to give you 240. And then so that is your area of the base. Okay. Now I need the height from base to base, which is 22. And if I multiply out 240 times 22, I get 5280 as my correct answer. That is the volume of the prism. Okay. Let's do a couple of cylinders now. So the formula for volume of the cylinder is pi r squared h. Now, just like the cylinders were a little bit easier than the prisms for surface area, they're also a little bit easier for volume as well, because once again everything is pretty much there for you. You don't have to do a lot of calculating like you do on the prisms. So radius 12, go 12 squared, height 15. That's all you need, and now it's just a matter of typing into a calculator and coming up with the answer. We can do that pretty easily. Let's see. Pi times 12 squared, alright, times 15. And so we come up with our volume, 6785.84. There you go. Okay, one more that we will try. This is also a cylinder that we want to find the volume of. We'll use the same formula, pi r squared h. And so when we go to plug in, we can see that we can get the radius pretty easily by cutting 7 in half to 3.5 squared. But now we need the height of the prism, and all they've given me so far is the slant height. Well, this is actually not even the slant height. It's from the one end, 3.5 squared, to the other end, 3.5 squared. of a diameter to the opposite end on the other side. So this is, I wouldn't even call this a slant height because there is no slant height in a cylinder. Okay, but what we can say is that if I look at this diameter, this height, and this diagonal, together they make a right triangle. So once again, we know that Pythagorean theorem will give us the missing side, which is the height. X squared plus 7 squared equals to 25 squared. And then if we go the square root of, move this over, so that'd be 25 squared minus 7 squared is 24. So 24 is the actual height of the cylinder. So I'll plug that in for H. We're good to go back to our calculator now and finish it off. And so we'll go pi times 3.5 squared times 24, 93.63. Or I said that wrong. 923.63 cubic units, and that's our volume. Okay, so like I said, two different formulas. Okay, just make sure you know what each part of the formula stands for and are able to calculate it correctly to plug back into the formula if need be, and then come up with the right volume. All right, so that's it.